Hello everyone, myself Samadhan Bodke. Today we are going to see how to find out the center of gravity of the composite figures. So here is the steps to find out the center of gravity or centroid. In my previous video, I have explained what are the steps to find out the centroid or center of gravity. You can see in my YouTube channel, and I will also add the description or a link in my description. Here also I will in short explain the steps to find out the center of gravity. Just place whatever object, composite body object in a first quadrant, first step. Second step, divide the object into simple solid bodies, that is suppose cylinder and cone, hemisphere and cone, like that. Find out the volumes. So here we are dealing with the center of gravity, so we are going to calculate the volumes of the solid bodies. Then find out the center of gravity of the basic figures, that is G1, G2 and G3, as we have calculated in centroid problems. Many centroid problems I have solved. You can check in my YouTube channel. Now the last step is using the formula x bar and y bar for the center of gravity. We are going to see for the CG we can use the formula x bar, and in case of x bar and y bar, in case of the center of gravity we have to use the volumes, and in case of centroid we have to use the areas. Just you have to keep in mind, for the cut section or remote section we have to take the area as a minus or volume as a minus. So here is the center of gravity of some solid figures or some commonly problems given on this solid figures, that is cylinder, cone, sphere and hemisphere. So first is cylinder. So just see over here diagram you can draw like this, and which is placed in the first quadrant as usual. So center of gravity of these figures will be x bar is equals to r, that is the center axis of symmetry will be like this. So x bar is the distance from y axis, so that will be equals to r, and y bar is distance from x axis. So cylinder is uniformly distributed to all, so h y bar is equals to h by 2, and volume of the cylinder will be pi r square h, as we know. Second one is cone. It is actually a right circular cone which is placed in the first quadrant. So x bar is equals to r, which will be x bar is equals to r, that is the distance from y axis. So what will be y bar? As you can see, most of the mass is concentrated at the base of the cone, so y bar will be equals to h by 4. So CG distance from this x axis will be equal to h by 4, and volume as we know 1 by 3 pi r square h. Now third object is sphere. So in the sphere we have placed the object or sphere in first quadrant. So same as the circle, its x bar and y bar is equals to r r, and volume will be 4 by 3 pi r cube. 4 by 3 pi r cube. And last one is hemisphere. So in the hemisphere we have placed the hemisphere which is placed facing towards x-axis, and its x bar is equals to r. So x bar is equals to r because it's symmetrical over this axis, and y bar is equals to 3r upon 8, that is distance of this CG from this center of axis will use 3r upon 8 if this hemisphere is facing towards upward direction. So this the distance of y bar will be equals to r minus 3r upon 8, r minus 3r upon 8. So can you can imagine various types of conditions for the hemisphere, like facing towards x, facing in upward direction, facing towards y-axis, facing towards right direction. So as per convenience, we can change our x bar and y bar, that is 3r upon 8, r minus 3r upon 8. Now volume of the hemisphere will be equals to 2 by 3 pi r cube. So here these are the simple composite figures we are using, we are going to use in the problem. So you have to learn this formula, center of gravity formula and volume formula. In the next video we are going to see one or two problems on the center of gravity. So thank you, thanks for the watch.